Hello friends, so in this session we will see some reasoning question based on carboxylic acid and its derivatives. Why all the acid derivatives are COG? So where G is it can be acid halides, amides or esters or anhydrates. So they are studied as a unit, means single unit we are studying for all acid derivatives. Because most of the acid derivatives are interconvertible and they can be prepared from the corresponding carboxylic acid. That's why they are studied as a one unit. Why the CG bond in acid derivatives is expected to be shorter and stronger than the alkyl derivatives, that is RZ. So let us check answers. Actually in RCOG, so this is nothing but the RCOG, the C uses the sp2 hybrid orbitals to form the bond with the Z. So this is the sp2 hybridization, and in case of, if you take RG, then this carbon present in R is using sp3 hybridization, hybrid orbitals with the G. So the increase in the S character make the bond shorter. So in this case the bond becomes shorter because this is sp2 and this is the sp3. So this is the bond is shorter and stronger. The presence of, because resonance is also present over in acid derivatives. The presence of resonance in acid derivatives makes the molecule more stable. So this is the reason. Why esters have lower boiling point than ketones, and the second is the acids of comparable molecular masses. So why they have lower boiling point? The positive charge on the carbon of the carbonyl group is in esters is comparatively less than that of ketones. So main thing is this is the positive charge. So this is the lesser on the carbon of the carbonyl group. So hence the weaker dipole-dipole attraction is present in esters than that of in ketones, resulting in lower boiling point in esters. Also the acids having the stronger intermolecular hydrogen bonding which are not present in esters. So boiling point of esters are less than that of acid. So out of these three acids, this is the amide, this is again next secondary amide, NHCO, again this is also amide. So in this case this ester amide having the highest boiling point, this has the highest boiling point and this have the lowest or minimum boiling point among three. So what is the reason? Reason is that it is simple, it is based on the hydrogen bonding concept. So in this case, third case, this has minimum boiling point because they have no hydrogen atoms on the nitrogen atoms. We can say there are no hydrogen atoms for the intermolecular hydrogen bonding. So it has the lowest boiling point. If you take the ester amide, it has two hydrogen atoms. So it has the highest boiling point. While in case of third, second, middle one, it has one hydrogen atoms and which contribute only one hydrogen bonding. That's why its boiling point is in between the first and third. How the order of reactivity to acid derivatives is related to the base strength of the leaving group. So we have to see the AC order of reactivity of the acid derivatives. So it is acid derivatives are we can say this is COCl, this is the ester, this is the OR, amides, this is anhydride. The order of reactivity of this acid derivatives are decreases as the base strength of the leaving group increases. So this is a very good leaving group. This is followed by this one ester, then anhydride, then Cl. So all we can say less electronegative atoms is more basic. So this is a nitrogen is less electronegative. This is more basics, more good leaving group. Then O followed by OR, then followed by this is more electronegative. This more Cl is the highest electronegative. So this is giving you less basic, very bad leaving group. This is very good, is good basics. More electrons are present on the nitrogen. So this becomes your more basic in characters. So that's why it is a very good leaving group. Why cannot HCl convert carboxylic acid to RCOCl, that is acid halide? If the reaction were to occur, the RCOCl and water product will react rapidly. What will happen? This RCOCl water they will react rapidly and they will form each other to form the starting materials. Means they will form the again acid chloride and water. So backward reactions occur more faster than the forward reaction. Why does an acyl chloride undergo nucleophilic attack more rapidly than does an alkyl chloride? So this is Rx. Why it happens? So actually nucleophilic attack on the tetrahedral carbon of the Rx nucleophilic attack on the tetrahedral carbon on R. The R contains the tetrahedral, it becomes a tetrahedral carbon. It involves the hindered transition state. Their transition state is hindered, and to permit the attachment of the nucleophile, a sigma bond must be partly broken. So since they are giving the hindered transition state, this is absent in case of acyl chloride. In this case, what happens in acyl chloride, the nucleophilic attack on this carbon group, it provides the unhindered transition states and leading to a tetrahedral intermediates. So thus, nucleophilic attack on the acid chloride occurs readily. What is the essential difference between the nucleophilic attack on the carbonyl of an aldehyde or ketone or on an acyl derivatives? We have to find the essential difference on the nucleophilic attack. In each case, what happens? The addition step leads to a tetrahedral intermediates. In whatever case, either you take this one or acyl derivatives, the addition step leads to a tetrahedral intermediate. They will form the tetrahedral intermediate, and this intermediate form from the carbonyl compounds have to eliminate the very strong base, and this intermediate they have to eliminate the strong base like H negative R. They are the very strong base from aldehyde and ketone respectively to restore the carbonyl compound, the CO group. The intermediate from the acyl derivatives is easily eliminated. In case of acyl derivatives, they will easily eliminate the G groups because they have the very good leaving group as compared to the hydride or R minus. That's why so this carbonyl and nucleophilic on the carbonyl of the aldehyde and ketones, and on an acyl derivatives are both are different. In this case, it is difficult, and for an acyl derivative, it is more easy. So these are more reactive than that of aldehyde and ketones. Carbonyl of aldehyde and ketones. Why a ketone is not isolated from the reaction of an ester with one equivalent of Grignard reagent? Actually, initially a ketone is formed. So as it is more reactive than ester to RMGX, tertiary alcohol is formed. So in this example, we can see there are 3 types of esters, the 4 types of esters, and among the 4 types of esters, this ester, why this is more readily hydrolyzed with sodium hydroxide? So let us see the answers. The size of the R, actually it depends upon the size of the R. So these are the R. Determines the age of hydrolysis. The larger the size of the R group, the greater will be the steric effect. So hence, this is a smaller, will be the hydrolyzed most steadily. So this is hydrolyzed mostly because they have a smaller R group. This is C4H9, this is the C3H7, this is the 2-methyl group reference. This is causing the large steric hindrance. That's why this will be least hydrolyzed among the all 4. Why formic anhydride cannot be prepared by heating formic acid? Actually, formic acid on heating undergo intermolecular dehydration rather than intermolecularly. So that's why this formic anhydride cannot be prepared by heating formic. Primary and secondary amide exist as a dimers in the solid and pure liquid state. Why it is occurring? So dimer formation is by actually hydrogen bonding. So you can see this is amide. So these 2 amide is forming dimers in these forms. That's why primary and secondary amide exist as a dimers in solid and pure liquid state. Why urea is basic? So we have to see this resonating structures first. So this is the formula of urea. So this lone pair will conjugate with carbon, and this will go negative charge. Oxygen will take the negative charge. So it will attain these states. This is the one resonating structure. Again, a lone pair of this nitrogen, again it can coordinate, it can conjugate with this carbon. So this pi electrons will shift to this one. So we will get another structure. So there are 3 resonating structures are there. That's why this is basic in nature. So it has 2 lone pairs on each nitrogen. So you get basic in resonance hybrid. In this hybrid also this is basic. Now this oxygen atoms carries the negative charges. So it will combine with proton to form the new OH bonds. So suppose this also combined with the proton to form new OH bonds, negative, and thus form is also stabilized by resonance. Again, after taking protons, this is also stabilized by resonance. You can see this resonance structures. So this is the accepted proton. So this becomes a OH. This is the enol. Again, this is a positive charge, so we can make this retinal structures. So it has one lone pair. So lone pair means what? It can this pi electron will sit this side. So this lone pair will give to this carbon. It will form these structures. Again, what will happen? This oxygen have a lone pair. So this pi electrons can give to this carbon, and this pi electron goes to this side. So this have two NH2 NH2. Again, we will get this third structure. So again, this is after taking the proton also, it is stabilized by resonance. Why guanidine is a strong monoacid base? So this is a monoacid base. So it can be explained by resonance stabilization of guanidian ion. So this is a guanidine. So this has 3 nitrogen in this part, and every nitrogen having one lone pair. So if one lone pair will coordinate conjugate with this carbon, so this will goes to this side, it becomes a negative charge. Second case, if this lone pair will come to this carbon, this will shift to this one. So again, these are third structures. So in this way, this nitrogen, this base is stabilized by the resonance stabilization. All ions are stabilized by the resonance. That's why this becomes your strong monoacid base. Why melting point of primary amide is higher than secondary and tertiary amides? Melting point of primary amide is highest due to the presence of hydrogen bonding. Therefore, melting point is decreases in the order. So this is the primary amide, secondary, tertiary, and quaternary. So this has a maximum hydrogen bonding. This has a one hydrogen, followed by lesser the hydrogen bonding than this one. This is the no hydrogen bonding, and this is again least hydrogen bonding. So this is also causing the stirring factor more than that of tertiary amides. So primary amide is always melting point of primary amide will be always higher than that of the secondary and tertiary amides. How urea is estimated? Urea is estimated by hypobromide method. So this is one method by which we can estimate the urea. So you have to know this method. A known volume of urea solution is treated with a sodium hypobromide solutions which contains sodium hydroxide. So after treating, the CO2 is evolved, and this is absorbed by the sodium hydroxide, and volume nitrogen also evolved, and this is measured in the nitrometer in the nitrometer, and from the volume nitrogen the amount of urea in the sample can be determined. So this only determines the amount of urea present in the sample. What are urites? So acyl derivatives of urea is called as the urites. There are two types. One is the simple urites and second is the cyclic urites. What is simple urites? So these are obtained by the reaction of acid halides and urea. For example, acetyl urea. What is cyclic urites? So these cyclic urites are obtained by the reaction of dicarboxylic acid or their derivatives and urea. For example, barbituric acids. So this is the cyclic urites. What is barbiturates? So barbiturates are the derivatives of barbituric acid in which two hydrogen atoms of the CH2 groups has been replaced by alkyl or allyl groups. You can see this is a CO group, this is NH2. If you remove this alkyl groups and keep H2, this is CH2, this is CO, and this is NHCO, this becomes your barbituric acid. But if you remove this two hydrogen from here and replaced by the ethyl group, this becomes your barbital. Similarly, if you replace this C2H5 by C6H5, then this becomes your phenobarbital. And these two compounds are actually sedatives in nature. So these are the barbiturates.